Out there, in the silence of space, each star holds a secret. This audiobook accompanies you for 2 hours on a relaxing journey through the most curious facts of the universe, colliding galaxies, impossible planets, mysteries that science still cannot explain. While you rest, your mind continues to travel, discovering that even sleep can be a path to the unknown, because the universe never sleeps and it always has something more to tell. What lies beyond our small blue planet? If we look up at the sky on a clear night, we can see thousands of stars twinkling in the distance. But how many of them are truly accessible to us? Scientists estimate that in our galaxy, the Milky Way, there are hundreds of billions of stars, and that's just a part of the total. Imagine the number of galaxies that exist, each with its own set of stars, planets, and perhaps life. As we explore this vast universe, we face fascinating questions. Are we alone in the cosmos? Are there other civilizations observing our small corner of the universe? The search for answers to these questions drives generations of scientists, astronomers, and curious minds to look up at the sky. Human curiosity is a powerful engine, and the universe is the canvas on which our deepest questions are drawn. As we embark on this journey, it is essential to understand that human knowledge has grown exponentially in the last century. With each technological advance, we have been able to observe beyond what our ancestors ever considered possible, from the first telescopes to the space probes that have crossed the boundaries of our solar system. Each discovery brings us one step closer to unraveling the secrets of the universe. Space missions, such as Voyager 1, have been key in our quest for knowledge. Imagine a small satellite traveling through the dark void of space, carrying with it the story of humanity. This journey has not only allowed us to obtain stunning images of distant planets, but has also sent a message to the cosmos. We are here, and we want to know more. The importance of telescopes cannot be underestimated. These instruments are our windows to the universe. Thanks to them, we can observe phenomena occurring millions of light years away, revealing the nature of our cosmos. As technology advances, so do telescopes, allowing us to see beyond what our eyes can capture. Each new design brings with it the promise of greater revelations. However, an intriguing question arises. Is it better to observe the universe from Earth or from space? Both options have their advantages and disadvantages, and the comparison between ground-based and space telescopes is crucial to understanding how we capture the light of the stars. While telescopes on Earth face atmospheric interference, space telescopes offer us a clear and unobstructed view, revealing secrets that would otherwise remain hidden. One of the most exciting advancements in astronomical observation has been adaptive optics technology, which has allowed telescopes to overcome atmospheric distortions. Imagine being able to instantly adjust the view of a telescope, as if you had a pair of magical glasses that eliminate any imperfections. This has led to a significant improvement in the quality of the images we obtain, allowing us to observe the universe with a clarity we never imagined possible. But the universe is not only populated with stars and planets. It also harbors extraordinary phenomena like black holes. These mysterious objects, which can devour everything around them, have captured the imagination of scientists and dreamers alike. How do they form? What is inside them? These questions are just the beginning of a vast field of study that takes us to the limits of our understanding. As we delve into these mysteries, international collaboration becomes essential. Astronomy is a global effort, where scientists from different countries work together to unravel the secrets of the universe. Examples like the Event Horizon Telescope show us how the union of resources and knowledge can lead to astonishing discoveries, such as the first image of a black hole, a monumental milestone in the history of astronomy. The search for exoplanets is also an exciting field. Using methods like transits and radial velocities, astronomers have begun to discover distant worlds that could harbor life. What are the chances of finding a planet similar to Earth? The answer to this question could change our understanding of life in the universe. Another intriguing concept we will explore is dark matter and dark energy, those invisible forces that seem to dominate the structure of the universe. Although we cannot see them directly, their influence is undeniable. What role do they play in the expansion of the cosmos? The answer is still being investigated, but each advance brings us closer to understanding the true fabric of the universe. As we reflect on these topics, it is important to consider how space exploration and the study of the universe impact our lives and our society. Scientific education becomes essential to foster a deeper understanding of the cosmos and its relevance to our existence. Are we really prepared for what the universe has to offer us? Finally, the universe is not just a collection of stars and planets. It is a reminder of our own fragility and the connection we have with everything around us. Each discovery invites us to be part of something greater, to not only look up but also to care for our planet. Curiosity and the desire to explore are inherent to humanity, and the universe awaits us with open arms. On this journey through the vastness of the cosmos, every question we answer opens the door to new inquiries, and so our adventure is just beginning. The vastness of the universe is a concept that can be difficult to grasp. Have you ever stopped to think about how many stars are in the sky? The answer is astonishingly large. It is estimated that in our galaxy, the Milky Way, there are between 100 billion and 400 billion stars. But that is just a small part of the whole. There are billions of galaxies in the observable universe, each with its own ocean of stars. Imagine an immense sea where each wave represents a star, all shining in the darkness of space. But what does all this mean for us? In the last century, our understanding of the cosmos has grown exponentially. Before, we looked at the sky and saw only bright dots. Now we know that each of those points can be a sun with its own system of planets, moons, and possibly life. Science has transformed our perception of the universe, making us aware of how immense and complex it is. Let's reflect for a moment. If the Milky Way is just one of billions of galaxies, what lies beyond what we can see? The answer is both inspiring and unsettling. Each discovery leads us to new questions. A century ago, the concept of an expanding universe was something almost unimaginable. Today, we know that it not only expands but does so at an accelerating rate. Can you imagine a balloon inflating faster and faster? That's how our universe behaves. Every star we observe is in some way a beacon that tells us about the history of the cosmos. Many of them have existed for billions of years, long before the Earth was even formed. When we look at the sky, we are not just observing displays of light, we are looking into the past. Some of those flashes we see may have disappeared long ago, but their light is still traveling towards us, crossing the vast emptiness of space. Human curiosity is insatiable, and as we learn more about stars and galaxies, we also question our place in this enormous universe. Are we alone? What else could exist in the infinite darkness? These questions have driven generations of scientists and astronomers to explore beyond the limits of the solar system. Every mission, every telescope launched into space aims to uncover the secrets that remain hidden. The history of humanity is intertwined with that of the cosmos, from the ancient Greeks who looked at the stars and formed constellations, to modern scientists who use advanced technology to study the light of distant stars. We have always been fascinated by the sky. Each new star discovered not only adds a point of light to our star map, but also adds a new layer of understanding about the nature of the universe. The growth of knowledge in astronomy has been astounding. In the 20th century, the invention of more powerful telescopes allowed astronomers to see beyond what had ever been seen. With each technological advance, we have been able to unravel more mysteries about the universe. But the most striking thing is that as we delve into this vast ocean of knowledge, we realize that each answer leads us to even more questions. And what about dark matter and dark energy? These are concepts that have challenged our understanding. In fact, it is estimated that nearly 95% of the universe is made up of these mysterious entities, which we cannot see or detect directly, but which nevertheless play a crucial role in the structure of the cosmos. Science is in constant search of answers, and each discovery opens the door to new inquiries. The data we obtain from the universe not only tells us about its past, but will also help us predict its future. The accelerated expansion of the universe raises questions about its ultimate fate. Will it continue to expand forever, or will there be a point at which everything collapses again? These are fascinating questions that scientists are trying to unravel. The immensity of the universe invites us to reflect on our own existence. In this vast cosmic stage, what is humanity's role? We are a small part of a much larger whole, but that does not diminish our importance. Each of us has the capacity to contribute to knowledge and exploration, whether through science, education, or simply sharing our curiosity with others. Thus, while we marvel at the number of stars and galaxies that exist, we must also remember that we are on a constant journey of discovery. Science is not just a quest for answers, but a process of wonder and exploration. Each advance brings us a little closer to understanding the secrets of the universe and, at the same time, reminds us of how much we still have to learn. The immensity of the universe is a reminder of how small we are, but also of how great our dreams and aspirations can be. Every star in the sky is an invitation to look beyond what we know, to question, to explore, and to marvel. In this vast cosmic ocean, curiosity is our best ship, and it is up to us to navigate towards the unknown. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Have you ever stopped to think about what lies beyond our solar system? In the vast ocean of space, there is a small probe called Voyager 1 that ventured beyond the boundaries we know. Imagine it as a little solitary explorer, traveling at speeds that seem unimaginable to us. Launched in 1977, its mission was to study the outer planets. But what began as a journey to Jupiter and Saturn has turned into an odyssey into the unknown, interstellar space. Voyager 1 has not only been a pioneer in exploration, but also faces challenges that are hard to imagine. The distance it has traveled is so immense that the signal it sends to Earth takes over 25 hours to arrive. It's as if it were sending letters from a distant civilization, and we are the lucky ones who receive them. But what has this little traveler learned on its journey into the unknown? Throughout its voyage, Voyager 1 has discovered that space is not an absolute vacuum, but a place full of mystery. It has captured stunning images of planets and their moons, but it has also provided data about the environment of interstellar space, where conditions are completely different from those we know on Earth. Can you imagine living in a place where gravity is almost non-existent and the cold is so extreme it could freeze time itself? One of the most significant moments of Voyager 1's mission was the famous pale blue dot, a photograph of Earth taken from a distance of over 6 billion kilometers. In that image, our planet appeared as a tiny speck in a vast sea of darkness. That image reminds us how fragile and solitary we are in the cosmos. Yet, despite our insignificance in the immense universe, Voyager 1 continues to send valuable data that helps us better understand our place in it. Exploring interstellar space is no easy task. Voyager 1 faces extreme radiation and an environment that challenges science. The particles it encounters are like tiny bullets that can damage its circuits, but thanks to its ingenuity and the meticulous planning of the scientists who designed it, it has managed to survive and continue its mission. What secrets will it reveal in its final years of life? The mission of Voyager 1 is not only a testament to human curiosity, but also to international collaboration. Engineers, scientists, and astronomers from different parts of the world joined forces to make this expedition possible. How many brilliant minds were needed to create a machine that could travel beyond our solar system? The answer is many, and each of them has left their mark on this story of exploration. As Voyager 1 ventures further into space, it shows us that knowledge knows no bounds. Every new piece of data it sends is a part of the cosmic puzzle we are trying to solve. What lies beyond what we know? Are there other solar systems with planets like ours? These are the questions that drive us to keep exploring and learning. Moreover, Voyager 1 also carries a message for any form of life it may encounter. Inside it is a golden disc containing sounds and music from Earth, along with images of our species and our planet. It's like a bottle thrown into the ocean of space, waiting to be found. How would beings from another world react upon receiving a greeting from humanity? The mission of Voyager 1 is far from over. Although it is now at the frontier of interstellar space, it remains an invaluable source of information. Scientists continue to analyze the data it sends, searching for patterns and answers to the questions we have asked since time immemorial. And while we do not know how much longer it will function, its legacy will endure for generations. Exploring space is not only a scientific endeavor, but also a journey of self-discovery. As we look toward the cosmos, we confront our own existence and the meaning of being human. What does the universe tell us about ourselves? Voyager 1, in its solitary journey, reminds us that we are part of something much larger. So as we continue to dream of future travels and discoveries, Voyager 1 invites us to reflect on what we have achieved so far. It challenges us to keep exploring, to keep searching, and to never stop asking, what other secrets does the universe hold? The answer to that question is what motivates us to look toward the stars, knowing that each discovery brings us a little closer to the truth. The observation of the universe has been one of humanity's greatest adventures, and telescopes are our windows to that vast ocean of stars. How is it possible that such seemingly simple instruments allow us to glimpse what is beyond our reach? On this journey through time, we have developed tools that transform light into data, revealing secrets that were once only distant dreams. Telescopes, in essence, function like a funnel for light. They capture light from celestial bodies and concentrate it, allowing us to see beyond what our eyes can perceive. But not all telescopes are the same. Have you ever wondered what makes some more powerful than others? The answer lies in their design and the technology they employ. From Galileo's early telescopes with their rudimentary lenses to today's sophisticated models, each advancement has been a step toward a deeper understanding of the cosmos. The history of telescopes is like a series of chapters in an epic book. In the 17th century, Galileo used his small telescope to discover the moons of Jupiter, something that changed our view of the universe. But what if I told you that those discoveries were just the beginning? As technology advanced, so did our capabilities to observe the sky. Larger and more powerful telescopes began to emerge, allowing us to see farther and with greater clarity. Imagine you are in a desert, far from the city lights, with a clear sky above you. You can see thousands of bright stars, but there is something beyond that beauty. Telescopes have gone beyond the visible. How have they achieved this? By utilizing different wavelengths of light, from infrared to ultraviolet, they allow us to study phenomena that would otherwise remain hidden. This ability to see beyond has led to astonishing discoveries, such as the existence of exoplanets and distant galaxies. Innovation in telescope design does not stop here. Each new generation of telescopes brings significant improvements. Can you imagine a telescope that can correct distortions caused by the Earth's atmosphere? That is precisely what adaptive optics does. This advancement allows real-time adjustments to the shape of the telescope's mirror, making images sharper and clearer. Thus, astronomers can capture details that were previously impossible to see. It's like having a pair of magical glasses that eliminate blurriness. Each telescope has its own personality and abilities. Some are designed to observe in space, away from the atmosphere that distorts images, while others remain on Earth, taking advantage of their location to study the sky. But what are the advantages and disadvantages of each? Space telescopes, like Hubble, have the advantage of being outside the atmosphere, allowing them to capture clearer and more precise images. However, their cost and the complexity of their maintenance are significant barriers. On the other hand, ground-based telescopes are more accessible, but they must deal with turbulent air that can affect image quality. Collaboration between telescope designers and astronomers is essential. Each new project builds on the successes and failures of the past. How do all these experts communicate? Often they gather at conferences and share their findings, creating a network of knowledge that drives astronomical exploration forward. This synergy is vital for the development of innovative technologies that enable us to observe the inconceivable. Telescopes are not just tools for observation, they are also bearers of stories. Each captured image is a tale of light that has traveled millions of years to reach us. What secrets do they reveal, from the formation of stars to the collision of galaxies? Each discovery brings us a little closer to understanding our place in the universe. Human curiosity is what has driven us to build and improve these instruments, and each new image is a testament to our relentless quest for answers. In summary, telescopes are more than mere devices. They are doors to infinity. The technology behind them has evolved astonishingly, allowing us to unravel the mysteries of the cosmos. As we continue to explore, we may wonder, what new wonders await us in the vast universe? The answer lies among the stars, and with each new telescope, we are one step closer to reaching them. The adventure is just beginning, and each discovery is a brick in the construction of our understanding of the universe. So keep your eyes on the sky and your mind open to what is to come. In the vast stage of the cosmos, telescopes play a fundamental role that goes beyond being simple optical instruments. They are our windows to the universe, tools that allow us to look beyond what our eyes can see. But what makes a telescope so special? Essentially, a telescope amplifies the light coming from distant objects, allowing us to observe galaxies, stars, and planets that are millions of light years away. Without these devices, our understanding of the universe would be limited and in many ways mere speculation. Telescopes have evolved over the years, from the first models made of glass to the sophisticated instruments we know today. In their early days, these devices were rudimentary, but the desire to discover the unknown drove significant improvements. Each advance in optics has allowed scientists to observe the universe with greater clarity and precision. Imagine an ancient telescope as a simple glass of water that distorts light. Over time, we refined that technique into a polished lens that reveals the beauty of the cosmos. Since the invention of the first telescopes in the 17th century, we have come a long way. The arrival of refracting and reflecting telescopes ushered in a new era of exploration. But what differentiates a refracting telescope from a reflecting one? The answer lies in their design. While refracting telescopes use lenses to focus light, reflecting telescopes employ mirrors. This simple change in construction allowed astronomers to capture more light and therefore see further. It's like moving from a flashlight to a lighthouse. The difference in reach is astounding. Today, we have telescopes that can observe objects so distant that their light has been traveling through space for billions of years. These telescopes not only show us the universe as it was in the past, but also help us understand how it has changed over time. For example, by studying the light from a distant galaxy, scientists can learn about its composition, age, and even its movement through space. Isn't it fascinating to think that we are looking into the past while observing the sky? However, not all telescopes are the same. Some are located on Earth, while others have been sent into space in search of a clearer, interference-free sky. Why is the location of a telescope so important? The answer lies in the atmosphere. Earth has an atmosphere that, while protecting us, also distorts the light from celestial objects. It's like trying to see through a fogged-up glass. Ground-based telescopes have to deal with this distortion, while space telescopes can observe without those obstacles. Imagine having a completely clear view of the universe. One of the most iconic examples of a space telescope is the Hubble Space Telescope. Launched in 1990, Hubble has provided stunning images and invaluable data about the universe, but what makes it so special? Its location in space allows it to capture details that would be impossible to observe from the Earth's surface. Every image it has sent back has revealed secrets of the cosmos, from star formation to the depths of galaxies. It's as if Hubble is a solitary explorer, navigating the vastness of space in search of answers. On the other hand, ground-based telescopes have also made significant contributions. Their large size and ability to make real-time adjustments allow them to capture high-resolution images. In fact, some telescopes on Earth are so large that they can observe details of nearby planets like Mars. Can you imagine being able to see a crater on the surface of Mars without leaving your home? That's the magic of modern astronomy. However, each type of telescope has its advantages and disadvantages. Space telescopes are ideal for observing distant objects without atmospheric interference, but they are expensive and complicated to repair. On the other hand, ground-based telescopes are more accessible and easier to upgrade, but they have limitations due to the atmosphere. It's a constant tug-of-war between technology and nature, a dance in which each tries to outdo the other. As we advance in our exploration of the cosmos, it is crucial that we continue to innovate in the design and construction of telescopes. Adaptive optics technology is an example of how we have improved our ability to observe the universe. This technique corrects distortion caused by the atmosphere in real time, allowing ground-based telescopes to capture sharper, clearer images. It's like having glasses that automatically adjust vision according to external conditions. With each new telescope launched into space or built on Earth, the possibilities for discoveries increase exponentially. Let's imagine for a moment the future of astronomy, telescopes that can see beyond what we thought was possible, revealing new worlds and mysteries that we have yet to imagine. Each of these instruments is a step toward understanding our place in the universe. Exploring the cosmos is a monumental task, and telescopes are our allies in this adventure. Through them, we not only observe stars and galaxies, but we also reflect on our own existence. What place do we occupy in this vast immensity? The answer may be closer than we think, but it depends on our desire to explore and discover. So the next time you look up at the night sky, remember that behind every star is a telescope that has worked hard to bring us a part of its light, a glimmer of knowledge that brings us a little closer to understanding the universe. Human curiosity remains the driving force behind these explorations, and telescopes, without a doubt, are the tools that will help us unravel the secrets of the cosmos. Adaptive optics is one of the most fascinating tools we have developed to understand the universe. Imagine trying to see through a fogged-up glass. No matter how hard you try, the image is always distorted, and you miss the details on the other side. This is how telescopes work when observing through the Earth's atmosphere, which acts like that fogged glass, distorting the light from stars and other celestial objects. But what if I told you that we have found a way to clean that glass and see the universe in all its clarity? The key to this improvement lies in adaptive optics. This technology allows a telescope to adjust its shape and focus in real time, compensating for the distortions caused by the atmosphere. How is this possible, you ask? The answer lies in a system of mirrors that constantly deform to adapt to changes in the atmosphere. Thus, every time a ray of light from a star enters the telescope, the system measures the alterations and adjusts the mirror to correct them. It's as if your eye had the ability to adapt to different lighting conditions instantly. This process is essential for obtaining sharper images of distant objects. Without adaptive optics, ground-based telescopes would struggle to compete with their space-based counterparts, which do not have to deal with the atmosphere. But with this technology, we have been able to achieve images that once seemed impossible. Can you imagine being able to observe the rings of Saturn with extraordinary clarity, as if you were right there? Moreover, adaptive optics not only improves the image of stars and planets, but also allows for the study of more complex phenomena. For example, it has been used to investigate the atmospheres of exoplanets, those distant worlds that orbit other stars. By correcting the distortion, scientists can detect the light that passes through the atmospheres of those planets and analyze their composition. Isn't it amazing to think that thanks to this technology, we could discover if there is life on a planet that is light years away? The evolution of adaptive optics has been impressive. In its early days, this system was rudimentary and limited the size of the telescopes that could benefit from it. But with advances in computing and sensor technology, we have been able to build larger and more powerful telescopes that effectively use adaptive optics. How does it feel to know that we can now observe the cosmos with a clarity that our ancestors could only dream of? One of the great achievements of adaptive optics can be seen in the Keck Observatory in Hawaii. This giant, with its 10-meter diameter mirrors, has revolutionized modern astronomy. Thanks to its adaptive optics technology, it has captured images of distant galaxies and provided valuable data on star formation. Imagine what we can learn by observing objects that are so far away and where the light has traveled for millions of years. However, adaptive optics is not without its challenges. The system must be extremely fast and precise, capable of making adjustments in milliseconds. Every time the wind blows or the temperature changes, the telescope has to recalibrate. This requires advanced technology and a team of experts working together. How exciting is it to think about the teamwork behind every image we see of the universe? Furthermore, telescopes that use adaptive optics are constantly evolving. Each new generation brings improvements that allow us to observe the universe in wavelengths that were previously inaccessible. For example, some telescopes are designed to observe in infrared, helping us see through cosmic dust that hides many young stars and forming planetary systems. Who could have imagined that we could see the birth of stars in such detail? The combination of adaptive optics with other technologies, such as spectroscopy, is taking our understanding of the universe to new levels. Spectroscopy allows us to break down light into its component colors, revealing the chemical composition of stars and planets. Together, these advances give us a richer and more complete view of the cosmos. As we move forward, adaptive optics will continue to play a crucial role in exploring the universe. Future telescopes, equipped with this technology, will be able to see beyond what we have ever imagined. What secrets does the universe hold for us? What discoveries are yet to come thanks to these innovations? So the next time you look up at the starry sky, remember that there is incredible technology that allows us to see beyond the simple light that reaches our eyes. Adaptive optics is a bridge between us and the vast universe, a reminder that there is always more to discover and understand. Are you ready to keep exploring? Black holes, those mysterious and fascinating phenomena of the universe, have captured the imagination of scientists and science enthusiasts alike. But what are they really? To understand it better, let's think of a magnet. Imagine a magnet so powerful that nothing can escape its pull. That's what a black hole is like. But instead of attracting metallic objects, its force is so intense that even light cannot escape its gravity. Can you imagine a place where light cannot escape? That is the essence of a black hole. These enigmatic objects form when a massive star exhausts its nuclear fuel. At the end of its life, the star collapses under its own gravity, creating a region of space where the gravitational force is immense. It's like trying to squeeze a balloon until it suddenly bursts. In the case of stars, the collapse generates a singularity, a point where density becomes infinite and the laws of physics as we know them cease to apply. Often there is talk of an event horizon in relation to black holes. This horizon is like an invisible boundary that marks the point of no return. If something crosses this boundary, it can no longer escape. But what lies inside? This is where things get really intriguing. The truth is that we do not know for sure what happens inside a black hole. Some theories suggest that we might be looking at a portal to another place in the universe or even to another universe. That sounds like science fiction, but scientists do not rule out any possibility. The importance of black holes goes beyond their mystery. It turns out they play a fundamental role in the formation of galaxies. Think of the supermassive black holes that reside at the center of many galaxies, including our Milky Way. These giants are believed to influence how stars group together and move, so in a way, black holes are like the architects of the universe. Without them, the structure of galaxies could be completely different. A question that often arises is, how can we detect something that does not emit light? It's a challenge, but astronomers have developed clever ways to observe the effects of black holes on their surroundings. For example, when a star gets too close to a black hole, it can be torn apart, and as the remnants fall toward the black hole, they heat up and emit radiation in the form of X-rays. These flashes of light allow us to infer the presence of a black hole, even if we cannot see it directly. The idea that black holes exist in the universe has been supported by numerous observations. In 2018, for example, an unprecedented feat was accomplished. The first image of a black hole was captured. This image, which shows the shadow of a black hole at the center of the galaxy M87, was a milestone in the history of astronomy. Seeing the shadow of a black hole was like peering into an abyss and confirming its existence in a way we had only imagined before. Black holes also force us to rethink our understanding of time and space. Within their event horizon, the rules we know may break down. Einstein's theory of relativity tells us that gravity can distort time. So what would happen if we could get close to a black hole? In theory, we could experience time differently, as if we were in a kind of time paradox. This raises fascinating questions about the nature of reality and the perception of time. One aspect that is often overlooked is the relationship between black holes and dark matter. Although they are two different phenomena, scientists are investigating whether they could be linked in some way. Dark matter, which makes up a large part of the universe's mass, does not interact with light and is therefore difficult to detect. Some researchers suggest that there could be a connection between the formation of black holes and the distribution of dark matter in galaxies. Could black holes be the keys to better understanding dark matter? Science is still trying to answer this question. In the field of cosmology, black holes also help us study the evolution of the universe. By observing how galaxies interact and merge, we can learn about cosmic history. Each supermassive black hole tells a story of growth and transformation, offering us clues about the events that shaped our universe. It's like reading the pages of a book that narrates the greatest story of all. In summary, black holes are much more than mere voids in space. They are complex entities that challenge our understanding and invite us to explore the limits of physics. They force us to question what we know and to keep searching for answers in a universe full of mysteries. As we continue to study these phenomena, each new discovery brings us a little closer to unraveling the secrets of the cosmos. So the next time you look up at the starry sky, remember that somewhere out there, black holes may exist, waiting to be discovered and understood. Their existence is not only a testament to the grandeur of the universe, but also a reminder that there is always more to know, more to explore, and more questions to answer. The exploration of the universe is an effort that goes beyond the borders of countries. It is a collective journey of humanity. International collaborations in astronomy have allowed scientists from all over the world to come together to study phenomena that would otherwise be beyond our reach. Have you ever wondered how these collaborations work and what achievements they have accomplished? Let's find out. When a group of researchers from different nations works together, an exchange of ideas, resources and knowledge is created that enriches each project. Imagine a giant puzzle where each piece comes from a different country. Each piece is unique and has special value, but when they come together, a much larger and more complex picture is revealed. This is how global astronomical projects are built. An emblematic example of this international cooperation is the Event Horizon Telescope, which captured the first image of a black hole. This project involved more than 200 scientists from over 20 countries. Through telescopes located in various parts of the world, their observations were combined to create a single image. Can you imagine coordinating so many researchers for a single goal? It is a true challenge, but the result is worth every effort. Communication is key in these collaborations. Scientists use modern tools that allow them to share data in real time, discuss their findings, and adjust their approaches on the fly. Just like a football team, where each player has a specific role but all work towards a single goal, researchers must be aligned in their objectives and methods. This not only improves the quality of the research, but also fosters a global community of scientists who support each other. Joint missions also allow access to resources that would otherwise be unreachable. Take, for example, the use of telescopes in remote locations. Some of the best sites for observing the sky are in inhospitable regions, where the cost of building and operating a telescope would be exorbitant for a single country. However, by sharing resources, several countries can build telescopes in these strategic locations and benefit from superior quality observations. Often, these collaborations are not limited to astronomical research. The technology developed for these missions has applications in other fields such as medicine, telecommunications, and meteorology. Who would have thought that studying black holes could lead to advancements in human health? This is how interconnected science and everyday life are. Astronomical events that require precise observation, such as eclipses or meteor showers, are also a fertile ground for international collaboration. When a spectacular phenomenon occurs, scientists from different countries organize to observe it from various locations. This allows them to collect valuable data and share their discoveries with the entire world. It's like a grand show where everyone is in sync, waiting to capture that magical moment. Not only scientists benefit from these collaborations, the public also plays an important role through online platforms. The results of these research efforts are shared and discussed. People from all over the world can access the data and participate in forums, democratizing knowledge and allowing more individuals to feel connected to the universe. Who hasn't felt excited watching a live broadcast of an astronomical event? Another fascinating aspect of these collaborations is the diversity of perspectives that different cultures bring. Each nation has its own history and mythology related to the starry sky. This variety of viewpoints enriches the scientific narrative and provides cultural context to the discoveries. How do the ancient legends of a people relate to the realities uncovered by modern science? It is a continuous dialogue between the past and the present. Collaborations also offer training and educational opportunities. Young scientists have the chance to work in international teams, learn from experts, and take their knowledge to new frontiers. This not only benefits the scientists in training, but also ensures that science continues to advance with new ideas and fresh approaches. The next generation of cosmic explorers is being forged in this collaborative environment. In today's world where global problems require collective solutions, astronomy becomes a shining example of how cooperation can lead to extraordinary achievements. These joint efforts foster a sense of community among countries, promoting peace and mutual understanding at a time when the world often seems divided. The quest for knowledge about the cosmos unites humanity in a greater purpose. In the end, international collaborations in astronomy are more than just research projects. They are a celebration of human curiosity and a reminder that, despite our differences, we all share an inherent desire to understand the universe we inhabit. What other wonders could arise if we continue to work together in this vast ocean of stars? The answer is in our hands, and the exploration is just beginning. Have you ever looked up at the night sky and wondered what lies beyond the stars? In the vast universe, there are phenomena that seem straight out of a science fiction novel, and one of the most intriguing is the black hole. But what exactly is a black hole, and why has it captured the imagination of scientists and dreamers alike? To understand a black hole, we first have to talk about gravity. Imagine that gravity is like a huge net that traps everything that comes too close. When a giant star runs out of fuel, it no longer has the energy needed to hold itself against the force of its own gravity. As a result, it collapses in on itself, and in this process it can form a black hole. But what does that really mean? It's as if a beach ball were crushed down to a tiny point, but with a gravitational force so powerful that not even light can escape its pull. The idea that something can be so dense and yet invisible is hard to grasp. So how do we know they exist? The answer lies in the way they affect their surroundings. By observing how stars move in the vicinity of a black hole, astronomers can infer its presence. It's like being in a park and noticing that even though you don't see a dog, you see other dogs running around excitedly, indicating that there is one hidden somewhere. Let's talk about the first image of a black hole, a milestone in the history of astronomy. In 2018, a team of scientists managed to capture the image of the black hole in the M87 galaxy. But how does one achieve something like that? It's not like taking a picture with your phone. This achievement required the collaboration of telescopes from around the world. creating a global network that acted as a single telescope the size of the Earth. Can you imagine how many people and how much data were needed to make this feat possible? The image they obtained shows a kind of shadow in space, surrounded by a bright glow. This shadow is the event horizon, the boundary beyond which nothing can escape. If you get too close to a black hole, it's like standing at the edge of a cliff. Once you cross that line, there's no turning back. But why is this image so important? Capturing the image of a black hole not only validates scientific theories, it also helps us better understand the physics of the universe. Black holes also play a fundamental role in the formation of galaxies. It is believed that many supermassive black holes are located at the centers of galaxies, and their presence can influence the formation and evolution of these structures. Imagine a huge magnet that attracts and organizes the dust and gas around it, creating stars and other planetary systems in the process. Moreover, black holes are natural laboratories that allow us to test the laws of physics under extreme conditions. What happens to matter and energy when they approach a black hole? These questions are fundamental for scientists trying to unravel the mysteries of the universe. Each new observation and each new discovery brings us closer to answering some of the deepest questions about the nature of reality. It's interesting to consider that although black holes are invisible, their influence is felt throughout the cosmos. For example, the supermassive black hole at the center of our own galaxy, the Milky Way, is called Sagittarius A. Its presence affects the movement of the stars that orbit around it, and by studying them, astronomers can learn more about the history and structure of our galaxy. The search for black holes and their study not only brings us closer to understanding the universe, but also raises philosophical questions about our existence. What does it mean to live in a universe where there are regions of space from which we cannot escape? And what about the possibility of wormholes, which could connect different points in space and time? While these ideas may seem fantastical, they are part of active research in theoretical physics. The fascination with black holes has also been a recurring theme in popular culture. From movies to books, these representations, although often dramatized, have helped spark public curiosity about these cosmic mysteries. However, it is essential to distinguish between fiction and science. What appears exciting on screen may, in reality, be a field of study filled with complexities and nuances. At the end of the day, black holes are a reminder of how little we truly know about the universe. Every discovery we make opens the door to new questions. The exploration of these phenomena invites us to keep questioning, to keep seeking answers in a cosmos that with each moment seems more vast and more mysterious. So the next time you look up at the stars, remember that behind that night sky there are black holes, forces of nature that challenge our understanding and inspire us to keep exploring. In such an immense universe, curiosity is our best tool. In the heart of our galaxy, the Milky Way, lies a fascinating mystery that has captured the imagination of astronomers and space enthusiasts for generations. This enigma is none other than the supermassive black hole known as Sagittarius A*. But what is a black hole, and why is it so important for understanding the cosmos? To begin with, a black hole forms when a massive star exhausts its fuel and collapses under its own gravity. This results in a region of space where gravity is so intense that nothing, not even light, can escape from it. Imagine you are in a deep pool and suddenly the water starts to drain towards a drain at the bottom. In a black hole, anything that gets too close will be lost forever, disappearing into an unfathomable abyss. The existence of Sagittarius A* was confirmed thanks to years of careful observations. Astronomers have studied the movement of stars orbiting this mysterious object and have discovered that these stars move at dizzying speeds. It's as if they are dancing in a cosmic waltz around an invisible center. But how is it possible for something so small to exert such a powerful force? The answer lies in the enormous mass of this black hole, which is estimated to be about 4 million times the mass of our Sun. Black holes are not just a topic of science fiction, they are crucial for modern cosmology. Their study helps us understand how galaxies form and evolve, By observing how Sagittarius A* affects the surrounding stars, scientists can gain insights into the history of our galaxy and how it has become what it is today. But what about its influence? Can a black hole even affect the matter and energy around it? The answer is a resounding yes. The enormous gravitational field of a black hole not only attracts stars, but it can also influence the gas and dust in its vicinity. This material can fall towards the black hole, forming a bright and hot accretion disk that emits X-rays and other forms of radiation. This phenomenon is similar to how water spirals down a drain as it leaves, creating a sort of whirlpool. Thus, as the material is consumed, an impressive amount of energy is released, which astronomers can observe with telescopes. Now, a big question arises: what lies beyond black holes? There are fascinating theories suggesting that additional dimensions or even bridges to other universes could exist. This concept, known as wormholes, is a hot topic in theoretical physics. Although these ideas sound more like science fiction than real science, they push us to think beyond what we know and consider the possibility that the universe may be even stranger than we can imagine. Black holes also play a crucial role in the formation of new stars and solar systems. Their gravity can attract material, forming new stars in the process. It's like a cosmic magnet that not only devours but also creates. This cycle of destruction and creation is essential for the evolution of the universe, reminding us that the death of one star can give rise to the life of another. By observing the black hole at the center of the Milky Way, scientists have been able to gather an impressive amount of information. The images we have seen, although they do not show the black hole itself since it is invisible, have revealed a world of activity in its vicinity. The images of the accretion disk and the radiation it emits provide valuable clues about the nature of these mysterious objects. Isn't it amazing to think that through observation we can glimpse what lies at the heart of our galaxy? The importance of black holes transcends the realm of astronomy. They also invite us to reflect on our own existence and our place in the cosmos. If we are able to understand these phenomena, perhaps we can also better understand the origin and fate of the universe. Each discovery brings us one step closer to unraveling the secrets that surround us. As technology advances, our tools for studying these fascinating objects also improve. With more powerful telescopes and innovative techniques, we are in a golden age of astronomy. The ability to observe black holes and their effects on the surrounding space has become a reality, and the questions that arise are as intriguing as their answers. So, when you look up at the night sky, remember that at the center of our galaxy, there is a black hole that, although invisible, is fundamental to the story of our existence. It reminds us that the universe is a place full of mysteries and that, in our quest for knowledge, each answer leads us to new questions. The exploration of black holes is just one of the many adventures that await us in the vast cosmos. And as we continue to inquire, human curiosity shines brighter than ever, illuminating the path to our future in the universe. In the vast immensity of the universe, there is a phenomenon that awakens our curiosity: exoplanets. What are they exactly? They are planets that orbit stars outside our solar system, and their existence leads us to wonder, could there be other worlds like ours? The search for exoplanets has gained impressive momentum in recent decades, and understanding how scientists detect them is like following the trail of a lost star in the sky. One of the most intriguing methods for discovering exoplanets is the transit method. Imagine you are observing a lamp from a window. If someone passes in front of the lamp, their shadow will briefly darken the light. Similarly, when a planet passes between us and its star, it blocks a small fraction of the light emitted. This slight dip in brightness is the clue that astronomers seek. By measuring the amount of light that dims and for how long, they can infer the size of the planet and its distance from the star. Isn't it fascinating how a simple play of lights can reveal so much about distant worlds? But what about planets that do not cross in front of their stars? This is where another method comes in, the radial velocity method. This approach is based on the gravitational influence that a planet exerts on its star. Imagine you are on a swing and someone sits next to you. Their weight causes the swing to tilt and move. When a planet orbits a star, it causes the star to move slightly as well. By observing the changes in the light emitted by the star, scientists can detect this movement. With this, they can deduce the presence of a planet and even estimate its mass. It's a cosmic dance between the star and its planet, and astronomers are the attentive observers of this choreography. As we advance in our search, we find astonishing planetary systems. One of the most fascinating is the TRAPPIST-1 system, which hosts 7 Earth-like planets, all orbiting a dwarf star. Imagine a group of friends walking in a circle in a park, each at a different distance from the center. Some of these planets are in the habitable zone, where conditions might be suitable for liquid water and therefore life. This raises an intriguing question. What kind of life could exist on those distant worlds? Would it be similar to ours or completely different? The discovery of these exoplanets not only excites us but also leads us to reflect on the diversity of the universe. There are planets of all sizes and compositions, from gas giants that could swallow several Earths to rocky worlds that might have atmospheres. How far does our imagination go when thinking about life in these places? Some scientists suggest that life could be more common than we think, but the distance between us and those worlds makes exploration a monumental challenge. However, technology is advancing by leaps and bounds. Telescopes like the Transiting Exoplanet Survey Satellite, known as TESS, are specifically designed to search for exoplanets. These telescopes are like treasure hunters in the vast stellar ocean. With their help, we have identified thousands of exoplanet candidates, many of which are waiting to be confirmed. Each new detection is another step toward understanding how planetary systems form and evolve. The search for exoplanets also raises questions about our own existence. If there are other habitable worlds, what does that mean for us? Are we alone in the universe, or are we part of a vast cosmic community? These philosophical questions lead us to reflect on our identity as a species and our place in the cosmos. The search for life beyond Earth is not just a scientific issue, but also an exploration of our meaning as human beings. Meanwhile, astronomers continue their work. Every day they receive new data and make new discoveries. The scientific community comes together in a collaborative effort, sharing information and resources to advance the study of exoplanets. This collaboration is a reminder that, although we are separated by great distances, we share the same starry sky and the same desire to understand it. As technology improves, the future of exoplanet detection is expected to be even more exciting. More advanced telescopes, such as the James Webb Space Telescope, promise to be capable of analyzing the atmospheres of exoplanets in detail. What unexpected discoveries await us? We might find signs of life in those atmospheres, or perhaps even planets that challenge our understanding of what it means to be habitable. The search for exoplanets is ultimately a journey of discovery. Each new finding brings us closer to understanding our own planet and the mysteries that surround us. It invites us to dream, to explore, and to ask questions. The universe is a vast ocean of possibilities, and we, as curious explorers, are just at the beginning of this exciting adventure. So, as we continue to look toward the stars, let us remember that each discovered exoplanet is not just a point of light in the sky, but a window to the unknown. Each of them has a story to tell and a potential to explore. The search for life beyond Earth is an invitation to keep asking, to keep discovering, and above all, to keep dreaming about what might be out there. The search for exoplanets is a fascinating journey that takes us to explore distant worlds beyond our solar system. What is an exoplanet? Simply put, they are planets that orbit stars other than our Sun. In such a vast universe, the idea that there may be other worlds with conditions similar to those of Earth is exciting. But how do we know they exist? The answer lies in some ingenious detection methods. One of the most commonly used methods for finding exoplanets is the transit method. Imagine you are watching a streetlight in the distance. If a bus were to pass between you and the streetlight, you would notice that the light from the streetlight dims briefly. This is the principle behind the transit technique. When an exoplanet passes in front of its star, it blocks a small fraction of the light emitted. Astronomers can detect it by observing a decrease in the star's brightness. This method has been crucial in identifying thousands of exoplanets, revealing that we are not alone in the cosmos. Another fascinating method is the measurement of radial velocities. Have you ever seen how a dog chases its tail? When a dog runs in circles, its body moves back and forth. Stars also move, albeit in a subtle way. When a planet orbits a star, the planet's gravity pulls on the star, causing it to shift slightly. Scientists can measure this movement using spectroscopy, observing how the star's light changes color. This change is known as the Doppler effect. By analyzing these changes, astronomers can infer the presence of an exoplanet and even estimate its mass. The variety of exoplanets we have discovered is astounding. Some are gas giants, similar to Jupiter, while others are rocky, like our Earth. But what makes a planet habitable? The answer lies in the habitable zone. This is the area around a star where conditions could be suitable for liquid water, an essential ingredient for life. If a planet's temperature is too high, water will evaporate. If it is too low, it will freeze. Finding an exoplanet in this zone is a crucial step in the search for life. The TRAPPIST-1 system is an exciting example in this context. This system, located just over 40 light-years away, hosts at least 7 planets, 3 of which are in the habitable zone. Imagine the possibility of oceans and continents on those worlds. The idea that we might find life on other planets has captured the imagination of scientists and dreamers alike. Who hasn't wondered if there are other beings looking up at the sky asking the same question? However, the search for exoplanets does not stop at finding Earth-like worlds. There are also planets that challenge our expectations, such as the so-called hot Jupiters. These gas giants orbit very close to their stars and have extreme temperatures. The study of these planets helps us understand how planetary systems form and evolve, giving us a more complete view of the diversity of the universe. Space missions have played a fundamental role in this search. Telescopes like Kepler and TESS have expanded our knowledge about exoplanets. Kepler, for example, has discovered thousands of them, while TESS searches for nearby bright planets to characterize them in detail. Technology is advancing, and with it, our capabilities to explore the universe. As our tools improve, so does our understanding of how planets form. The most accepted theory suggests that planets form from disks of gas and dust around young stars. Over time, these materials clump together and form planets. But why are some planets rocky and others gaseous? The answer to this question is part of the cosmic puzzle we are trying to solve. The search for exoplanets also raises profound philosophical questions. If we find life on other worlds, how would this change our perspective on ourselves? The idea that we are not alone in the universe could have a significant impact on humanity. It invites us to reflect on our own existence and our place in the cosmos. Are these exoplanets just distant worlds, or are they also echoes of our own history? Each discovery of an exoplanet brings us one step closer to answering these questions. Science is advancing rapidly, and each new finding opens the door to more mysteries. The exploration of exoplanets is an adventure that is just beginning, and each of us has a role in this story. Human curiosity drives us to seek answers and explore the unknown. In the coming years, future missions such as the James Webb Space Telescope will allow us to study the atmospheres of these exoplanets in detail. The possibility of detecting signs of life such as oxygen or methane is closer than ever. What will these explorations reveal about the possibility of life on other planets? The search for exoplanets is a reminder that the universe is full of surprises. Each discovery brings us closer to understanding that life, in its many forms, could be a common phenomenon in the cosmos. In the end, we are on a collective journey that transcends borders and civilizations, uniting humanity in the quest for answers about our place in the vast universe. Curiosity remains our guide, and the sky is just the beginning. Dark matter and dark energy are like two great mysteries surrounding the universe. They are like the shadows that shape what we see, yet we cannot touch or see them. How is it possible that most of the matter in the universe is invisible? It is estimated that dark matter constitutes about 27% of the total mass and energy of the universe. This means that out of every 100 parts of everything in the cosmos, about 27 are dark matter. However, what exactly is dark matter? Scientists have concluded that dark matter does not emit light, nor does it reflect light, making it completely invisible to our telescopes. But then how do we know it exists? The answer lies in the way galaxies move and how gravity acts on cosmic scales. For example, if we observe a rotating galaxy, we notice that the stars at its edges move at speeds much greater than they should if only visible matter were present. It's like spinning a ball tied to a string. If the string breaks, the ball will fly straight. But in galaxies, it seems there is something keeping those stars in place, and that something is what we call dark matter. Now let's move on to dark energy, which is even more puzzling. Dark energy is believed to represent about 70% of the universe's content, unlike dark matter, which holds visible matter together. Dark energy appears to be driving the universe to expand faster and faster. Imagine you are inflating a balloon. At first, the balloon expands steadily, but then suddenly it starts to inflate at a faster rate. That's what is happening with our universe thanks to dark energy. The question many scientists are asking is, what is dark energy? We still do not have a definitive answer. Some theories suggest it could be a property of space itself, a kind of energy that fills the vacuum of the universe. Other theories see it as a phenomenon related to gravity on large scales, but so far it remains one of the greatest puzzles of modern cosmology. Imagine you are in a vast ocean. Around you is water, but there are also currents pushing you in different directions. In this cosmic ocean, dark matter would be like the current that keeps galaxies together, while dark energy would be the mysterious force pushing everything outward, causing the universe to expand. This duality creates an unstable balance that scientists are trying to understand. Research on dark matter and dark energy is a constantly evolving field. Scientists use telescopes and experiments in underground laboratories to try to detect dark matter particles. Sometimes these efforts feel like searching for a needle in a giant haystack. However, each new discovery about these mysterious forces can change our understanding of the universe in unexpected ways. One of the keys to unraveling these mysteries may lie in international collaboration. Teams of scientists from different countries work together, sharing data and resources to advance research. This is crucial, as the amount of data generated is overwhelming, and it is only through collaboration that we can begin to make sense of it all. Dark matter and dark energy are not just abstract concepts, they have real implications for our understanding of the universe and our place in it. Without these two components, the very structure of the cosmos would collapse. Galaxies, stars and planets, including our Earth, would not exist as we know them. This leads us to a fascinating question. What would happen if they did not exist? Imagine a sky without stars, a universe where gravity cannot hold galaxies together. Reflecting on dark matter and dark energy also raises a philosophical question. What does it mean to be human in such a vast and unknown universe? We face the reality that there is much we do not know. But that also presents us with an opportunity. Curiosity and the desire to explore are part of what defines us as a species. The quest for answers to these questions could inspire future generations to continue exploring not only the universe, but also the very nature of existence. In a sense, dark matter and dark energy reflect our own search for meaning. Just as scientists attempt to unravel these cosmic mysteries, we too seek understanding in our own lives. It is a reminder that, although we may not always have all the answers, the journey toward knowledge is what drives us forward. The future of research into dark matter and dark energy is promising. New telescopes and missions are in development, and each advance brings us a little closer to solving these enigmas. Perhaps in the not-so-distant future we will come to understand how these invisible forces shape the universe. Human curiosity has led to great discoveries, and who knows what surprises the cosmos holds for us. So, as we look up at the starry sky, let us remember that there is much more than meets the eye. Dark matter and dark energy are just a part of a cosmic puzzle that we continue to try to solve. At the end of the day, what truly matters is that we keep asking questions and seeking answers, for it is that search that connects us to the universe as a whole. The exploration of the universe has taken a revolutionary turn in recent decades thanks to the arrival of next-generation telescopes that promise to unlock secrets that remain hidden. Have you stopped to think about what this means for our understanding of the cosmos? Technology is advancing by leaps and bounds, and with it, our ability to observe and understand what surrounds us. Telescopes have been our eyes in the sky, from the early models of Galileo to the sophisticated instruments that orbit our planet. Each advancement has expanded our view of the universe, but how is this achieved? Through the innovation and dedication of scientists and engineers who not only want to observe but also to understand. The telescopes currently in development are designed to be much more than simple observers. They are meant to be explorers that unravel the deepest mysteries of the cosmos. Imagine a telescope that can see beyond what our eyes can capture. This is possible thanks to cutting-edge technology that allows the detection of not only visible light, but also other wavelengths, such as infrared and ultraviolet. These telescopes can observe phenomena that were previously invisible, such as the first galaxies that formed after the Big Bang. Isn't it amazing to think that we could be seeing the universe as it was billions of years ago? The next generation of telescopes is not just about the ability to see farther, but to see more clearly. Adaptive optics, for example, is one of the most exciting innovations in this field. This technology corrects the distortion caused by the Earth's atmosphere, improving image quality and allowing us to observe details that were once just a dream. Can you imagine being able to see the surface of a distant planet clearly enough to distinguish its features? But it's not just about the clarity of images, it's also about the amount of information these telescopes can gather. New instruments are designed to capture data at unprecedented speeds. This means that astronomers can study phenomena in real time, such as star explosions or the movement of asteroids. What discoveries could we make if we could observe the universe as it happens? International collaboration is a fundamental aspect of developing these telescopes. Scientists from around the world are working together, sharing knowledge and resources to create tools that transcend any borders. How powerful is teamwork when it comes to unraveling the secrets of the universe? This cooperation is leading to the creation of telescopes that are true engineering marvels. A notable example is the James Webb Space Telescope, which promises to revolutionize our understanding of the cosmos. This telescope is designed to observe the universe in infrared wavelengths, allowing it to see through clouds of gas and dust that hide many wonders of space. What secrets will this new eye in the sky reveal? The anticipation for its first findings is palpable among the scientific community and the general public. The exploration doesn't stop there. Other projects, such as the Extremely Large Telescope, are on track to be built, and they are expected to offer unprecedented resolution and sensitivity. How will this change our view of the universe? With each new advancement, we get closer to answering questions that have intrigued humanity for centuries. The impact of these telescopes on scientific research goes beyond astronomy. The technology developed for them has found applications in diverse fields such as medicine and engineering. Isn't it fascinating how the quest for knowledge in the universe can benefit humanity in multiple ways? Education also plays a crucial role in the future of astronomy. As new technologies and telescopes are developed, it is essential that new generations are prepared to use them. Curiosity and the desire to learn are driving forces behind innovation. How can we inspire young people to become the scientists and explorers of tomorrow? As we enter this new era of cosmic exploration, it is essential to remember that each discovery brings us closer to understanding our place in the universe. What does it mean for us as human beings? That we are in a constant search for answers. The exploration of the cosmos is not only a scientific endeavor but also a reflection on our own existence. The telescopes of the future will not only change our understanding of the universe but will also unite us as a species. Each finding will remind us that we all share a home in this vast cosmos. What wonders lie beyond our current reach? The answer is on the horizon, waiting to be discovered. So as we look to the sky and dream of what could be, let us remember that each new telescope, each new technology is one step closer to understanding the unknown. Are you ready to be part of this exciting adventure? The exploration of the universe has only just begun, and you are a part of it. The exploration of the solar system is like an epic journey in an adventure book where each planet and moon has its own story to tell. From the warmth of the sun to the icy cold of distant worlds, every corner of our cosmic neighborhood is filled with surprises. But how have we come to know more about these fascinating places? The answer lies in space missions, true heroes that have crossed space to bring us valuable information. Did you know that the first major step in the exploration of the solar system was the Mariner probe mission, which sent the first images of Mars in 1965? Imagine the excitement of scientists receiving those images, as if a book had opened with pages full of secrets. Since then, we have sent numerous robotic explorers that have roamed the surface of Mars, uncovering clues about its history and its potential to harbor life. Each mission has its own personality. Let's think about the Voyager probe, which began its journey over 40 years ago. This small spacecraft was launched in 1977, and its goal was simple: to visit the outer planets. But who could have imagined that it would also become the first man-made object to reach interstellar space? It's as if a small love letter had left our solar system to tell other worlds about us. Speaking of Mars, one of the most exciting missions was that of the Curiosity rover. This robotic engineer has been exploring the Martian surface since 2012, analyzing rocks and searching for signs of water. Who wouldn't get excited thinking that perhaps one day we could walk on its terrain? The search for life, past or present, has become one of the main objectives of Martian exploration. Now let's change course to Jupiter. The Juno probe has been studying this gas giant since 2006, but what makes Jupiter so special? Its size and its immense atmosphere filled with storms like the Great Red Spot teach us a lot about planet formation. Juno has not only provided us with stunning images, but has also revealed data about the composition of its atmosphere, like a detective unraveling a cosmic mystery. And let's not forget Saturn and its majestic ring system. The Cassini mission, which lasted nearly 20 years, gave us spectacular views and great knowledge about this planet. Can you imagine traveling between those rings and watching them spin around you? The probe allowed us to discover that Saturn is not only beautiful, but also has intriguing moons like Enceladus, which may harbor oceans of liquid water beneath its surface. The moons of Jupiter, like Europa, have also captured our attention. The exploration of this moon has been like a fairy tale where the possibility of life beneath its icy crust makes scientists dream of the future. What secrets do those hidden oceans hold? The upcoming Europa Clipper mission will launch in the coming years to seek answers. Each mission has opened new doors to understanding the solar system, from the asteroid Bennu, which the OSIRIS-REx probe recently visited, to the mysteries of Pluto explored by the New Horizons probe in 2015. Each of these missions has contributed to a cosmic puzzle that we are beginning to decipher. How many more surprises does the universe hold for us? The exploration of the solar system is not just about science, but also about inspiration. Each discovery reminds us of how small we are in the vast cosmos. What if we were just a grain of sand on the beach of the universe? These missions connect us not only with other worlds, but also with each other as humanity in the quest to understand our place in the cosmos. As we look to the future, there are countless planned missions that promise to take us even further. The Artemis mission aims to return humans to the moon, and not only that, but also to prepare us for future trips to Mars. Who can foresee what wonders we will find at those destinations? Human curiosity is insatiable, and each mission is another step toward new frontiers. The exploration of our solar system is a testament to what we can achieve when we come together to pursue knowledge. Each launch of a spacecraft is like a new chapter in our collective story. With each discovery, we get a little closer to answering fundamental questions. Are we alone in the universe? What other worlds might harbor life? In conclusion, the exploration of the solar system is not just a scientific endeavor. It is a human journey into the unknown, a call to adventure that inspires us to keep exploring, learning, and dreaming. So, as we continue to look to the stars, let us remember that each mission, each probe, each discovery is a reflection of our insatiable curiosity and the desire to understand the vast and wonderful universe that surrounds us. The relationship between Earth and the universe is like a vast ocean where each wave represents a discovery, a connection that reminds us that we are part of something much larger. But have you ever stopped to think about how this cosmic immensity impacts our daily lives? Every star that shines in the night sky is not just a point of light, it is a reminder that we are interconnected with everything around us. Earth, that small blue planet, plays a fundamental role in the vast stage of the cosmos. Every breath we take, every water cycle, and every change of season are intrinsically linked to the forces that operate in the universe. How can this be possible? The answer lies in the laws of physics that govern both our planet and the rest of the cosmos. For example, the gravity that keeps us firmly anchored to Earth is the same that keeps the Moon in orbit and the planets on their paths around the Sun. As we explore the universe, we discover that the matter and energy surrounding us are part of an endless cycle of transformation. Did you know that the atoms that make up our bodies were forged in the hearts of stars that exploded millions of years ago? We are not just inhabitants of Earth, we are in essence stardust. This thought not only connects us to the cosmos, but also invites us to reflect on our responsibility towards the planet we inhabit. With each astronomical discovery, we are reminded that Earth is an oasis in the vast desert of space. However, this oasis is fragile. Pollution, climate change, and the destruction of natural habitats are just some of the challenges we face. The connection between Earth and the universe urges us to take care of our home. What if each of us decided to make a small change in our daily lives to protect this oasis? The sum of our actions could have a significant impact. Celestial phenomena also teach us about temporality. Stars are born, shine, and die, and with each death they give rise to new generations of stars and planets. This cosmic dance reminds us that every moment on Earth is precious. The question is, how do we make the most of that time? Curiosity and the desire to learn are powerful engines that can guide us on our journey through life. Speaking of curiosity, what about future generations? The way we understand our connection to the universe influences how we educate our children and how they relate to the world around them. Fostering scientific curiosity and critical thinking is not only vital for humanity, but also provides them with tools to face the challenges of the future. Imagine a world where the next generation looks at the stars and instead of merely admiring them, wonders how they can contribute to the exploration and conservation of the universe. Moreover, advancements in space technology have allowed our view of Earth from space to become clearer. Images of our planet from orbit have revealed the beauty and fragility of our home. Have you ever wondered how these images impact our perception of Earth? The perspective from space helps us see the interconnectedness of ecosystems and the need to care for them. Every continent, ocean, and atmosphere is intrinsically linked, and what happens in one place can have repercussions in another. Space exploration is not just a journey into the unknown, it is also a journey towards self-understanding. With each mission to space, we learn not only about the universe, but also about ourselves. The technology we develop to explore other worlds, such as satellites and telescopes, also applies to improving our quality of life on Earth. Who would have thought that space research could lead to innovations in medicine, agriculture, and communication? The connection between Earth and the universe is also manifested in our cultures and mythologies. Since time immemorial, humanity has looked to the sky for answers. Constellations have guided navigators, and lunar cycles have influenced agriculture. This story of connection reminds us that we are part of a much larger whole, and that our actions have repercussions that go beyond the immediate. In this context, the question that arises is, What legacy do we want to leave? The way we care for Earth and explore the universe will resonate with future generations. Do we want them to inherit a degraded planet and an unexplored universe? Or do we want them to find a vibrant home in a cosmos full of opportunities? The choice is in our hands. Finally, human curiosity is an essential engine that drives us to look toward the stars. Every question we ask and every answer we find brings us closer to understanding our place in the vast universe. Exploration does not stop. It is an endless journey that requires our attention and effort. By embracing our connection to the universe, we not only enrich our lives but also cultivate a sense of responsibility toward our home. Earth, are you ready to be part of this cosmic adventure? The space industry is in full expansion, and its impact on scientific research and the exploration of the cosmos is more palpable than ever. But what does this growth really mean? How has it transformed our understanding of the universe? To understand this, we must first consider how space exploration was a few decades ago. It was a world where missions were limited to large government agencies and where access to space seemed a distant dream. Today, however, the situation is very different. More and more private companies are taking the reins of space exploration. One might think it's just a simple business, but in reality these companies are revolutionizing access to space. Think of it as if space were a vast library filled with ancient and valuable books, but only a few people had the keys. Now, with the arrival of new companies, that library is opening up to everyone, allowing more researchers and scientists to access its secrets. Space missions have shifted from being exclusive to becoming an opportunity for collaboration. In this new scenario, not only are major powers sending rockets into space, small startups are contributing innovations that once seemed impossible. Imagine that each rocket launched not only carries technology, but also fresh ideas and new perspectives to the universe. This diversity of thought is essential to tackle the challenges that still lie ahead. Did you know that space tourism companies are starting to offer trips to space? This new trend might seem like a whim of the wealthy, but it's much more than that. By opening space to more people, we are creating widespread interest in science and exploration. It's as if we are inviting everyone to be part of a grand adventure. Moreover, each person who goes to space becomes an ambassador for science, capable of inspiring others to look up and wonder about the universe. The space industry has also driven the creation of innovative technologies that have found applications in our daily lives. For example, the satellites orbiting Earth are not only tools for exploration, but are also essential for communication, navigation, and weather observation. Every time you use your phone or check the weather online, you are leveraging technology that was born from space exploration. It's as if space has given us a toolbox that we continue to use on Earth. One of the most fascinating aspects of this growth is how it has led to an increase in investment in scientific research. Companies are investing billions of dollars in developing new technologies and conducting experiments that could answer fundamental questions about our universe. Imagine that every dollar invested in the space industry not only seeks economic benefits, but also seeks answers to the deepest mysteries of existence. As the industry expands, so does the need to educate the next generation of scientists and engineers. Universities and schools are beginning to offer programs focused on space exploration and associated technology. Who knows? Perhaps the next great discovery will come from a child inspired by current advancements and deciding to dedicate themselves to science. This is like planting seeds in a garden. Every investment in education is a promise of future growth. However, the growth of the space industry also raises important questions about sustainability. As we launch more rockets and satellites, we must ask ourselves, are we taking care of our planet? Space exploration should not come at the expense of our Earth. Therefore, it is crucial that companies and governments work together to develop responsible and sustainable practices. Missions to Mars are a clear example of how collaboration between nations and companies can lead to astonishing discoveries. When several organizations come together for a common goal, the results can be remarkable. Each mission brings not only the possibility of discovering if there is life on other worlds, but also the opportunity to learn more about our own planet and its history. In the end, the space industry is a reflection of our innate curiosity. We have always looked to the stars, wondering what lies beyond. Now, thanks to the collaboration between the private sector and governments, we are in a privileged position to explore and learn more effectively than ever. Each advancement brings us one step closer to unveiling the secrets of the universe. With each launch, each new technology, and each discovery, we are writing a chapter in the history of humanity. Space exploration is a collective effort that transcends borders and cultures. It reminds us that regardless of our differences, we all share the same home in a vast universe, and that knowledge is the key to our future. So as we enter this new era of exploration, it is vital that we continue to support and foster scientific curiosity. The space industry is not just a pathway to the cosmos, but also an invitation for all of us to dream big and reach for the stars, not only in space, but in our own lives. The adventure is just beginning, and the universe is full of possibilities waiting to be discovered. Satellite technology has transformed the way we observe the universe and our own planet. But what makes these devices so crucial for modern science? Essentially, satellites are like eyes in the sky, capable of seeing what is happening thousands of kilometers away. They can capture details that would otherwise remain hidden. But how do they manage to do this? To understand it better, let's think about a camera. If you take a photo from a considerable distance, you might capture a general view. But if you zoom in, the details start to become visible. Satellites do something similar, but instead of focusing on a single point, they can cover vast areas. Thus, with their advanced technology, they can observe everything from changes in the climate to the migration of animals on Earth. One fascinating aspect of satellites is their ability to monitor the weather. Did you know that thanks to them, we can predict storms and hurricanes? Imagine a program that analyzes patterns in the ocean and the atmosphere. The data collected by satellites allows meteorologists to anticipate extreme weather phenomena, saving lives and property. Without these instruments, many of the predictions we take for granted would be little more than guesses. Space exploration also benefits greatly from satellites. These devices not only allow us to observe our nearby environment, but are also essential for exploring other planets. For example, satellites orbiting Mars have provided invaluable information about its surface, atmosphere, and climate. Without them, the possibility of a manned mission to Mars would be even more complicated and dangerous. Speaking of exploration, satellites also play a crucial role in the search for exoplanets. How? Through a technique called transit, which involves observing the decrease in light from a star when a planet passes in front of it. Satellites dedicated to this task, such as the Kepler Space Telescope, have discovered thousands of worlds beyond our solar system. This leads us to wonder how many of these new lands could harbor life. In addition to their role in astronomy, satellites are fundamental for modern communication. Have you ever wondered how you can watch YouTube videos on your phone, even when you're in the middle of nowhere? The answer lies in communication satellites. These send and receive signals that allow information to travel over great distances, connecting people around the world. Without them, our ability to communicate would be drastically limited. Satellite technology has also revolutionized navigation. We have all used map applications on our phones to find the best route to our destination. But how do those apps know exactly where we are? They use data from global positioning satellites, or GPS. This system allows a device to determine its location with astonishing accuracy, changing the way we travel and move around the world. However, not everything is advantageous. The proliferation of satellites also poses challenges. Have you ever wondered what would happen if the amount of space debris continues to grow? Every satellite launched into space carries the risk of colliding with another piece of debris or even another satellite. This risk can affect not only communication and exploration, but also the safety of astronauts and space missions. It is also important to consider how satellite technology has contributed to scientific research on Earth. From monitoring deforestation to observing the oceans, satellites provide us with crucial data to understand our planet. For example, thanks to them, we can track the melting of glaciers and the consequences of climate change. This data is vital for making informed decisions about conservation and the use of our resources. The global interconnectedness provided by satellites also impacts education. Have you ever thought about how students in remote areas can access scientific information? Satellites have enabled the most distant communities to access the internet, facilitating education and the exchange of knowledge. This is especially important in a world where information is power. In the field of medical research, satellites are also doing their part. Did you know they can help track the spread of diseases? By analyzing patterns of temperature and humidity, scientists can predict outbreaks and help contain epidemics. This rapid response capability is crucial for preserving public health in an increasingly interconnected world. Finally, we cannot forget the role of international collaboration in the development of satellite technology. Countries around the world are working together on projects that transcend borders. This not only strengthens diplomatic relations but also enriches global knowledge. By joining efforts, scientists can tackle complex problems and find more effective solutions. The future of satellite technology is promising, with the advancement of artificial intelligence and the miniaturization of devices. We can expect satellites to become more efficient and accessible. Can you imagine a world where every person has access to real-time satellite data? This could change the way we interact with our environment and with each other. Satellite technology is not just a scientific tool, but a window into the universe and our own planet. It allows us to explore, communicate, and better understand our place in the cosmos. As we continue to advance, it is essential to remember that these technological wonders are the result of human ingenuity and global collaboration. Each discovery opens new doors to even deeper questions about the universe we live in. Human curiosity is undoubtedly one of the most powerful engines of our advancement. Since time immemorial, we have looked at the night sky and wondered what lies beyond our atmosphere. How is it possible that a simple flash of light in the darkness becomes the spark that ignites the flame of knowledge? Scientific education plays a fundamental role in this quest, allowing us not only to understand the cosmos but also our place within it. Science is not just a collection of data and complex formulas. It is a window into the universe. When we teach new generations about astronomy, physics, and biology, we not only provide them with technical knowledge, but also equip them with a tool to question, explore, and dream. Who hasn't felt that thrill when learning about the vast distances between stars or the possibility of life on other planets? That excitement is the first step toward a deep understanding of the universe. Scientific education, then, is like a star map. Without it, navigating the vast ocean of knowledge can be overwhelming. But what would happen if we didn't have such a map? Misinformation could lead us to believe in myths and legends instead of proven realities. For example, without proper education, we might think that the Earth is the center of the universe, when in reality we are a tiny dot in an expanding galaxy. Every discovery in science is like a small star that lights up in a student's mind. By learning about black holes, galaxies, and exoplanets, young people become explorers of the cosmos. But what happens when they are not given the opportunity to explore? The lack of access to quality scientific education can lead to a disconnection between people and their environment. Without knowledge, it is easy to lose sight of the beauty and complexity of the universe. Scientific education is not just about theory, it is also about practice. Imagine a group of students looking through a telescope for the first time. That experience, that direct connection with the cosmos, can be transformative. By seeing craters on the moon or the rings of Saturn, they are not just learning about the solar system, they are living science. The excitement and wonder become a motivation to keep investigating. Educational programs that promote science in classrooms are crucial. Initiatives like astronomy clubs, school observatories, and visits to planetariums can spark interest in young people. But how can we ensure that everyone has access to these opportunities? The answer lies in collaboration and community commitment. Schools, governments, and non-profit organizations must join forces to make scientific education a priority. Moreover, technology has revolutionized how we learn about the universe. With a simple click, we can access quality educational resources. From documentaries to interactive simulations, knowledge is closer than ever. But in the face of this avalanche of information, a question arises. How do we discern between what is true and what is a myth? This is where scientific education comes in, teaching us to analyze, question, and validate information. And what about the importance of scientific outreach? Scientists have the responsibility to communicate their findings in an accessible manner. When a researcher shares their work with the public, a bridge is created between the academic world and society. This not only increases interest in science, but also fosters an environment where questions are welcome. Curiosity becomes a continuous cycle of learning and discovery. Scientific education also helps us tackle global challenges. Issues like climate change, public health, and sustainability require a solid understanding of science. By empowering people with knowledge, we can make informed decisions that positively impact our planet. Science provides us with the necessary tools to address these problems, but first, we must understand how it works. Meanwhile, the connection between science and everyday life is stronger than we think. From the technology we use to the medicine we consume, science is present in every corner of our lives. By promoting scientific education, we are preparing future generations to become informed and critical citizens. A future where science is an integral part of education may seem distant, but every step counts. Some may think that science is only for scientists, but that couldn't be further from the truth. We are all part of the vast universe, and we all have the right to understand it. As we educate future generations, we empower them to explore, question, and most importantly, to dream. In conclusion, scientific education is not just important, it is essential. It helps us understand our place in the universe, fosters curiosity, and prepares us to face the challenges of the future. So when we look at the starry sky next time, let us remember that each star not only represents a distant destination, but also an opportunity to learn, explore, and grow. Science invites us to be part of this journey, and it is our responsibility to ensure that everyone has the chance to join the adventure. The vast universe offers us countless mysteries and discoveries that invite us to reflect on our place within it. As we explore the data of the cosmos, a fundamental question arises: what do these data really mean for us, human beings? Every star we observe, every galaxy we discover is a reminder of how small we are, but also of how great our aspirations can be. Human curiosity has been the driving force that propels us to look up at the sky and wonder what lies beyond. The history of humanity is intertwined with the desire to understand the universe, from the ancient astronomers who gazed at the stars in awe to modern scientists using advanced telescopes to unravel their secrets. We have come a long way. Each discovery we make brings us closer to a universal truth. But what is the true value of this quest? The answer may lie in the connection we establish with our environment and with ourselves through knowledge. Exploring the universe not only teaches us about the cosmos, but also helps us better understand our own planet. As we learn about the formation of stars and planets, we also begin to understand how Earth was formed and the conditions necessary to support life. Each new finding offers us a fresh perspective on our home, revealing the fragility and beauty of our surroundings. Imagine that every piece of data collected about the universe is like a piece of a giant puzzle. Some pieces are large and easy to identify, like the existence of exoplanets, while others are smaller and more complex, like the nature of dark matter. As we put these pieces together, we start to see a clearer picture of how everything works. But what will happen when we finally complete this puzzle? What new questions will arise in our minds? One of the wonders of science is that there will always be room for more questions. Every answer we find opens the door to new uncertainties. The pursuit of knowledge never ends. It is a continuous journey that takes us to new frontiers. In this sense, the universe becomes a vast book in which every page read invites us to keep exploring. Human curiosity is like a spark that ignites the fire of exploration. It drives us to step out of our comfort zone and venture into the unknown. What would happen if we did not have that curiosity? Perhaps we would never have launched probes into space or built telescopes to look beyond the clouds. Exploring the universe is not just an academic exercise, but an expression of our essence as human beings. As we look to the future, it is essential to remember that knowledge is not a luxury, but a necessity. In a world where information flows rapidly, understanding the universe allows us to make more informed decisions about our own planet. Scientific education becomes a fundamental pillar for creating a society that values curiosity and exploration. The youth of today are the scientists, engineers, and explorers of tomorrow. What legacy will we leave them if we do not nurture their curiosity? The responsibility to inspire the next generation rests with us. Every discovery we make in the universe should be shared, not only to celebrate our achievements, but to motivate others to keep inquiring. The interconnectedness between Earth and the universe shows us that every action we take has an impact. Science is not just a field of study, it is a pathway to sustainability and the preservation of our home. By better understanding how the universe works, we also gain the knowledge necessary to care for our planet and protect it for future generations. The future of space exploration is promising. With every new telescope launched, with every satellite placed in orbit, we are one step closer to answering questions that have existed for centuries. The space industry is booming, and its growth will not only benefit science, but also our everyday lives. Who knows what wonders we will discover in the next decade? In summary, the data of the universe are more than numbers and statistics. They are stories that connect us to the unknown. Each discovery offers us the opportunity to reflect on our existence and our role in the cosmos. They remind us that although we are insignificant in the vastness of the universe, our questions and our desire to explore are what define us as a species. Exploring the universe is not just a journey into the unknown, it is an invitation to dream. Every star in the sky is a reminder that, although the future is uncertain, there is always room for curiosity and hope. So let us continue to look up, continue to ask questions, and above all, continue to explore. The adventure is just beginning.